Okay, so welcome to the second day of the user exchange, the Destinationers user exchange. Today we have 2 sessions in a row in the morning with a break, and there will be some food and coffee, tea at the back of the room. So I invite you to join and enjoy also the poster session. You have new poster today. And then in the afternoon there will be the checkpoint session when you can get more insight on the user feedback. Along the end of the user exchange, you will still have Slido open. There is a QR code exactly here. So please raise your question there, and we will take them at the end of at least of the session we will start now. I will co-share this session on data and services in Destinationers with Oriol, which is a cloud data engineer working on DestinE. And I will introduce now the session with the data portfolio. You probably heard about it quite a lot, and I will detail a bit more its content and how it's enabled. Okay, so the DestinE data portfolio is tailored to user needs. Again, it's an evolving catalog of data that is composed of the new digital twin data produced within DestinE, together with federated data. And there is the ambition to also integrate the generated data produced within DestinE ecosystems through applications. All those data exposure has an agreed and specified life cycle, which is available in a data portfolio document. It goes along the phases of DestinE. This catalog is implemented by the data lake architecture, which stores some data close to the HPC centers, the digital twin data produced by ECMWF, so that it consists of the climate adaptation digital twin together with the extreme event ones, and also close to other big data stores, such as the EUMETSAT one, a data store maintained and operated by Cloudflare in Warsaw. So, but it's not only, so this catalog is not about only Earth observation or weather data. It also includes some statistical data from Eurostat. There is a connection with the GRC data catalog. Today we have a small extract, but there is the wish to extend it. Also, we try to demonstrate to connect with more data, for example, on aircraft, such as IAGOS, and together with other data sets produced by ESA and ECMWF. So please, if you need to get this portfolio extend, talk to us, talk to the Destinationers team. As I said initially, it's user-driven catalog. Here it's enabled, as I said, with the architecture of the data lake, so through federation and by hosting the data, digital twin ones. And all of this is exposed to the platform developed by IDA, and that's your entry point to DestinE. This one, you have some links. I don't know if you will have access to the presentation later on, but here you have the website to get more insights on it. Here, regarding the user-generated data, as I said, user can upload their data in DestinE following some quality gates control, of course. Today, we have received 6 requests for adding them. So we have a board with all interested entities, validated also by the Commission. We evaluate the relevance, let's say, of the data. So all of them were approved. And now we are in the process to add them within the catalog. And there are 2 of them are now in staging, well, even in production, but with restricted access, for user to test, and then it will be discoverable by you. I will conclude now on this one. So I will introduce Michel Schick from EUMETSAT, System Manager, who will develop a bit more how what are the different services which enable the access of digital twin data, because there is not only one. I will also introduce, together with Michel, Ines Sanz from ESA and Thiago Quintino, sorry for your name. And yeah, the floor is yours. Thanks.
Good morning, everybody. This is a joint presentation by the 3Es, by the three of us. And so for accessing digital twin data, we have many different services that you've seen potentially on the core platform. And we want to give a bit better overview what exists there, what you can maybe do for it, and make it a bit clearer for you what you can choose or what you can use for that. So I have at the beginning 2 slides which point to the ECM WMF fact sheets about the 2 digital twins. So if you scan the QR code, you get to the entire fact sheet prepared by ECM WMF, and it explains you the key features of the climate change adaptation digital twin. And in the moment you can see the climate scenarios and the projections are done in 3 different model versions. And you see the years covered there, and we have as well the storylines. You can read up of the key features as well on the right side, and I have here the same again for the weather-induced extremes DT. So this one points as well to a fact sheet where you can see the key features and how actually the data is being provided for the weather-induced extreme DT. So this one is run daily or scheduled daily, and then it provides you data for 4 days in the future. And so there's later coming this year as well the on-demand, but maybe Thiago or over coffee, Niels can tell you more about that. So now I give the floor to Ines.
Yes, so the platform is the user access point for all the data generated by ECMWF, the DestinE data, and also for other data sets. So the platform, behind the service registry of the platform, there is like a data model, that's how we want to call it. Each of the services lists in the service registry all the data sets they give access to. So this way we can look for the services based on the data sets that are available. Right now, so the platform represents an ecosystem of services. We are starting to feed the platform with multiple services, but for now, main functionalities that are addressed by the service registry are data access and processing and visualization. So you can check, there is a web, like a link inside the platform that is called DestinE Data Portfolio, and in this page we tried a bit to explain what are the different options to access DestinE data, because there are multiple options, because we know the community is very broad and very diverse, and we think that different purposes and different end users will need different ways to access the data. So here is a list of all the data that give access to all the services that give access to the DestinE data, and they give access to the DestinE data through different interfaces, different formats, and different projections. We will go a bit through these services later on in the presentation, but this is a summary. And in the page, you can click and you can go to each of the services to test them. There is also the service that is called Insula, that I think most of you should know about it. It's a service with Jupyter notebooks that allows you to test all the data access services. For accessing digital twin data, you need to have upgraded access and have this upgraded access approved by the European Commission. And in order to have this upgraded access, everything is explained in the website. You have to register, and then you have to request the access, and you have to request the access with a professional email address. A personal email address is not allowed. So just for you to know, if sometimes people are rejected just because they are using Gmail, not because they are not allowed to access the data. But we try to be in contact with these people through the support of the platform so they can modify the address. And yeah, and that's it. And this is like a summary of how we can access the data. We're going to start by Polytop with Thiago from ECMWF.
Right. So as Ines was saying, we have a broad user base, and therefore we have many ways of accessing the data. And so Polytop is like at the back end, and other ways are then built on top. Why would you want to use Polytop? Well, what you get with Polytop is that you get the direct access to the data on its native format, on its full resolution, raw, unaltered, right? If you are a scientist wanting to get just to the data and hasn't been touched, no guarantees that it hasn't been touched, that's maybe the way. But there's a little bit more. Some things we can do is that we can have server-side interpolation. So maybe if you're someone who does not have many resources to then process the data, or you can already do some data reduction directly on the server side before we send it to you. And another thing is that this is still being worked on, the last one, which is we will allow soon to get directly access to data that is still freshly computed on the HPC and hasn't yet been moved to the data bridges. If you go through Polytop, then you get that extra access. I believe with HDA too. And finally, Polytop does give you one more thing, which is the feature extraction. The capability of not only having the fields of the atmosphere, but also being able to go and just getting a few bytes. So I want a time series, I want a four-dimensional flight track, or I want, for example, an ensemble on a particular point. All this is possible without having to extract the whole hypercube. So we go through and just get the axis that you request. Aside from Polytop, we also develop another service called Aviso. The idea of Aviso is that you can be notified when data is available. This is not built for people, this is built for workflows to integrate with workflows. So if you have a downstream workflow from DestinE, you want to process something, this is designed to do, when this happens, or when this data is available, please do that, right? And so when we notify that, say, there's a new climate DT variable, or there is a new extremes DT available, then plot my data, or update my website, or run my analysis, right? So it's really meant to systems to integrate with systems. And then finally, we have a toolkit that we are developing that is for users to use downstream of DestinE, so maybe in your own laptop. Idea being, it's called EarthKit, it's a collection of open source software that interoperates with the community standards, things like Xarray, Pandas, PyTorch, etc. Designed really to be easy to learn, to lower the learning curve as much as possible. We have a running tagline within our development community: one line to get the data, one line to process it, one line to plot it, right? Of course, it tends to be more than that, but we aim that simplicity. So in order to reduce boilerplate code, and why would you want to do this? What is different about this toolkit? There are, of course, other toolkits out there. We are not trying to compete with them. The difference here is that below the scenes, inside of EarthKit, we use the same software and the same processing mechanisms that we use to prepare the data. So in a certain way, it's consistent. It's bespoke to the data. It recognizes, oh, this is this particular data, I should interpolate it in this particular way. That's the advantage of using that. And finally, it is designed with GPU and in-memory computations from the onset. So behind, for example, if you heard about Anemoy, ECMWF framework for machine learning, this is actually one of the building blocks of Anemoy. So it is designed to quickly get the data in memory, process it with minimal disk I/O and so on, so that you can be very efficient in your work. So, and we have this integrated with HDA, we have this integrated with Wikio, thanks to Ometsat. Idea being, you write your code, and in few lines, you can get the data from DestinE, and you can plot it.
Okay, going back again to the picture, I detail a little bit more on the entire picture. So you can see when we go from the right side to the left side. So users have the capability to choose between different services and applications to access the digital twin outputs. And if you go as far to the right, you have much more flexibility, but you have to write maybe more code. And then towards the left side, it goes towards sort of no code. On the left side, if you see the applications, for example, like Eden, Sesame, or the data cache management system, they have as well slightly different capabilities and skills, and also slightly different APIs. So for example, if you use Eden or Sesame, you have as well the capability that inside the browser, once you access the data is visualized, and you can maybe interactively interact with it in the browser. So you have graphical user interfaces, you have API as well provided there, and then on Polytop or on Harmonized Data Access, you have an API, and you can use it in combination, for example, with EarthKit. And you can see here from the flows of errors how everything has been used. So it's all starting with the Hypercube, which is receiving the data from the climate adaptation digital twin in HealPix, and the ExtremeDT. So it's been stored in the Hypercube, and the only way to get this out is through Polytop. But Polytop is used then by the other applications to sort of provide it through their APIs. You may have as well, in Eden or Sesame, additional data offering. So sometimes you read some lines on the website, data more than the DestinE data portfolio or additional data. And so there may be some additional data sets that you can find there that you don't see in the DestinE data portfolio, but the service providers providing these applications, they provide it as part of their offering. And then we have something specific, which is a data cache management system, which is actually taking the data from Polytop and store it in a different format, ZAR, and for the climate.dt in a different projection, lat long, and in a different resolution, and a subset of parameters. And so the data cache management is meant to support many users which can actually work with this more optimized or lower resolution. So like the DestinE streamer, etc. So going now to the HDA, Dana L said that before, so I would not repeat that. The Harmonized Data Access provides discovery and data access, various data providers. We have about 200 collections, also the DT collections itself. And you use, in all of the applications, one credentials. So your credentials and your upgraded account, you can use it for any of the applications. All of the applications and services are free to use, so there's no charging, etc., and anyone can use them. So here's an example of the Harmonized Data Access. It's similar to what Thiago has shown. So you can use it in Jupyter Notebooks. You can do here, the plots that you see here are done with EarthKit, for example. And then we have as well, for all of the applications that are provided that you saw on the diagram before, you find in Jupyter Notebooks examples of how to use the APIs, how certain data is visualized or plotted. And you can, for example, have a look at the climate.dt plotter or ExtremeDT plotter. It's a Jupyter Notebook, and there you can select the different parameters, select the different models, and get the idea of how it works. And you could extract as well the little bit of code and then paste it directly into access to Polytop. So now I'll go back to you, Ines. Or I go on? Okay. So we were not quite clear who does what. So here on this one, so I mentioned before, you can test it in various means. And quite popular is to use Insula on the core platform. It's a Jupyter Hub. And on there you find the different labs. So you see here on the left side, it's a platform lab. Then you find the Lake lab, and you find as well a lab for ECMWF, Polytop, EarthKit, and Aviso examples. And you can load these notebooks and with your credentials and play through. We have as well, as part of the Edge service offers, and only the Edge services are available on request. And once granted, there's as well a Jupyter Hub, which we call Stack, which can operate near the data. And it's similar like the Insula service. The only difference is it's close to the data. You can use Dask as well to do distributed computing on the various bridges. And here are some plots. And the credit for the plots is again to EarthKit here, which we used. You want to say this, Ines?
It's just the conclusion that all services are open and free for everyone, so please register in the platform and test the services through Insula. I think it's quite friendly usage, and so please register. And there is a survey going on that where we are going to review all the feedback from users and try to adapt the evolution of the system to the user community. So please. If you want to contribute, the QR code is there. Thank you.
I think that's it from our side. And I think in the room there as well, maybe some people for the application service that we shown. So I think if you want to know more about Polytop, there's Thiago there, but also colleagues from him. On the HDA, some people from EUMETSAT are there. And I think Ines from your side, for example, there is for Eden. Yes, there are people there, so you can ask Ines, and then she can point you to the people to find out more. Thank you very much.
Thank you very much. I invite the audience eventually to ask the question, either in the room, there are microphones in the middle row, or through Slido. We don't have questions so far, but I have one. So within the picture, when there are all the services exposed and the link between them, it's, or I'm not sure it's well said, let's say, or Polytop and HDA directly also exposed to the users. And yeah, that's my question.
Yeah, I mean, they are all, yes, all of them, both HDA and Polytop, they are APIs, right, in the end. So these are services that both have APIs and users can contact directly. And for example, if you want to, say, do a little bit of data fusion, for example, get satellite data and get climate data, maybe you go to the HDA and you pull both and you visualize. If you want to deal directly with the heel picks and you want to do feature extraction, maybe you go to Polytop. I think this is the richness of DestinE. Like, you have multiple ways of getting to the data, and this is really linked to maybe what Babis was saying yesterday, to the question, who are the users? When we have so many users in DestinE, and different users will use the platform in different ways. So I think the richness of the APIs and the availability is very important.
Thanks, Thiago.
Sorry, I just wanted to add that this diagram is also a dynamic diagram. So the link between the services might change with time depending on what the needs of the user community.
Thanks, Ines. Yes, I see one question. Please. Yeah.
Hi. I'm curious about EarthKit. So we have started using it, and it's really, really handy. It really allows us to do quick things with ERA5, DestinE data. And I'm wondering to what extent EarthKit is ready to support other data sets, such as when you run your climate model and you want to do regrading and other operation with your raw climate model data.
So that's a very good question. So EarthKit really is still under development, okay? And it started like about 2 years ago. And we're really developing it, hopefully, in the open sufficiently that the community feels that they can work with us, okay? And so I urge you, if there is something you think is missing, or there's something you think we can do better, or something you would like to contribute, get in touch. It's all on GitHub. It's all open. We want to reach out and make sure it's suitable for you too. We use it, so we eat our own dog food if you want. So we use EarthKit internally for a lot of our post-processing, but we also want to give it out to see if it's useful for other people. And please do get in touch. EarthKit, by the way, it's not only for DestinE. It was not designed only for DestinE. We designed it for our own operations, okay? But we felt that was useful enough that maybe others could be interested, so we put it out there.
Thank you. I see another question, and one online later.
Yes. Is that working? Yeah. I don't see OpenEO here, and I wonder because, for example, on the CDSE that is being kind of very much promoted. Is there anything, or which tools do you share with, for example, CDSE to make sure that users can work on either platform with the same code and don't have any issues when switching between the platforms?
I try first, and then Thiago comes. So, I mean, in the moment we considered, or we looked at OpenEO for the implementation, for example, as part of the workflow manager which is called Hook on the edge services. And so there is some sort of similar code bases so that you can execute workflows based on OpenEO, but OpenEO has not been completely implemented in there, at least on the data lake. And on the core platform, I don't know, or if Thiago wants to add something. So, I mean, it could be considered in the future that something could be added, but so it's only so far as what I mentioned.
Maybe I would like to put that the other way around. Maybe use one of these surveys that we are pointing to get in touch and tell us what you would like to see. I think this is why you are here, right? This is exactly what the user exchange is about. Is to get to meet users and ask you, what would you like to see? If you think there's a way we should be integrating with OpenEO particularly, let's have that conversation, and we are open to that.
Thank you. So I see two online questions. There is one which is about DestinE Data Lake list climate DT for only a certain time frame, 2025, but the climate DT website says the coverage is until 39. Why is the difference? I think it's just an update which is needed. I don't know if you mentioned you refer to the data catalog, the data portfolio URL, or when you research with Stack. We have noticed this, and it should be corrected soon. So thanks for highlighting this point.
I would like to answer to this question. I think we need to discuss offline where you saw this difference, because in the API and the access, you can access the full amount of data available in the models. So that should not be the case. Maybe somewhere on the collection documentation or somewhere there is a configuration not correct, but the data is accessible. So we can take it offline. And then the second is for you, Ines.
Yeah, the second question is asking why is access denied to normal email providers? This is part of the terms and conditions for using the DestinE data. You can find the terms and conditions at the bottom right, I think, of the website. So they are open to everyone. And the DestinE data are restricted for professional usage. So that's why the approval needs to be linked to a professional email address.
Okay, thanks a lot for the nice engagement, the questions, and also I hope this presentation answered to a question we had quite often, why we have so many services. So thanks a lot for your presentation. I will now welcome Miruna from EUMETSAT, who will present the age services introduced probably, I'm sure, earlier yesterday, but now we will go more into detail.
So, good morning, everyone. My name is Miruna Stoicescu. I am part of the DestinE Data Lake team at EUMETSAT. And I am going to talk a bit more about the what we call the edge services in DestinE. So just a quick reminder, I guess you've seen already this diagram. We call it internally in EUMETSAT the onion diagram, because it shows the different layers of the data lake. So the DestinE data lake in a nutshell, what is it? It's a self-standing component within Destination Earth. It's built from geographically distributed systems, or elements. This is hidden from the end users because they can seamlessly access data and services that are located a bit all over Europe. In the center of the onion, you can see the discovery and data access element, via which we provide access to digital twin outputs and a wide area of federated data providers. Around it, you can see the edge services, and these services are not only for data access. It's very important to say that the data lake is not only about storing data and providing access to it, but also for doing near data processing so that users don't have to download massive amounts of data to their environment before they can run their applications. And around it, you have the user-driven data portfolio that Daniel described in detail, to which we can add data sets as needed by the different use cases that we onboard. Here you can see in this visualization a possible user journey on our services. So the users come via the core service platform on the left-hand side. They access our services, so they discover the data offering that we have. They discover the big data processing or edge services that we provide. They can request virtual machines, so in order to set up their own infrastructure if they have this need, or they can use higher level services for doing processing. They can develop AI/ML applications. They can bring maybe already existing processing chains. They can access digital twin data. You can see on the right-hand side the 2 digital twins, or as well data from the different data spaces. And after they have done their processing, maybe in an iterative way, they get home the results. And they leave the system. It's very important to mention that these results, if they prove to be interesting for the user community, they can become what we call user-generated data. So they can request that the data that they have produced within their applications is added to the DestinE data portfolio. Here you can see an overview of the services, so of the edge services. So at the top we have the harmonized data access that Michael described in detail right before. So we provide access to all the data portfolio via a standardized stack API. I think there was a question before about the commonalities with CDSC. So this is one commonality, for example, the fact that we offer data via the stack protocol, which is well known and used. And then in the lower part of the diagram, you can see the big data processing services. It's important to mention that these services are free. The only thing is that you have to request access to them. So once you are on the desk, you can access our harmonized data access for the federated data providers, but you still need to request access to the digital twin outputs. The access is free, it's just that there is a matter of approval. And then in order to get these resources for the big data processing, you have to make a separate request. There's going to be some QR codes afterwards for the procedure that you have to follow. So we have 3 flavors, more commonly known as infrastructure as a service, software as a service, or function as a service. We wanted to be a bit more creative, so we created our own names. Islet, so it's inspired, with islands or islets, so it's for people who want to be kings or queens of their own environment, so they need to set up their own virtual machines or Kubernetes clusters. Stack, so that's for people who want to stack applications, so they don't care so much about managing their own infrastructure. So here we have Jupyter Hub and Dask and Dask Gateway. And hook at the bottom, so these are higher level functions that you can hook directly in your own code. So here we have predefined workflows or custom workflows. The first contacts are how do you get to these edge services. So when you go to the desk, you have a section in the services that is called Access DestinE Data on the Edge. In there you are going to find our services, as well as I think the Polytope, for example, is also in the same section. And once you click on them, you get access to the documentation and as well to our own user interface. Michal has mentioned this before, so the key features of the harmonized data access, all the data is available via the Stack interface. We have a single set of credentials. You don't need to worry about the underlying access protocol of the federated data providers because we provide access via harmonized interface. And you can access this API in a Jupyter Lab environment provided by our Stack service, or on Insula, or on your own local environment, or on virtual machines that are offered by our DDL islet service. The Stack service, so in this offering we have Jupyter Lab and Dask clusters. You can see on the left-hand side a diagram of a use case that was executed, and the link at the bottom. So it was a use case showcasing the Italy drought in 2022. It's important to say that we have the Jupyter Enterprise Gateway and Dask clusters that are available on all of the DDL sites, so on all of the data bridges as well on the central location. And in this environment, you can access our HDA via multiple ways, directly via the API, via PyStack, and via the EODAG client. So what I was mentioning before, the Jupyter Enterprise Gateway that is deployed everywhere and allows you to run processing near the data of interest, so either on the bridges or on the central location, if you are interested in the in federated data, for example, on the Sentinels or so. You have also multiple plugins already deployed, so you have GitLab, Dask, S3, and EODAG. So you can directly mount buckets, so to give you access to the, so you can get directly access to object storage where we host what we call the fresh data pool, so that's a massive amount of satellite data, or buckets where you have your own data. We have a DDL kernel that is the default Python environment, which comes with pre-installed libraries, and you also have a lot of examples available via our GitHub. The islet service, so here as I was saying, you want to manage your own environment because you have maybe some complex processing chains that you are bringing from your own work, so from your own environment. Here you have a virtual environment based on OpenStack. You have pre-configured images, blueprints. You have Magnum managed Kubernetes clusters. And very important, we give a CPU and GPU resources. So this is particularly interesting in case you are interested in AI/ML applications. And then we have another flavor of islet, so the islet storage. So here is access to S3 storage. You can manage your buckets, and we also have, you can manage complex access control lists and so on. The hook service, so these are here we have predefined hooks. The most interesting one is the data harvester. So it allows you to harvest data that is accessible via HDA and bring that data to S3 storage prior to processing. So it can be private S3 storage or temporary S3 storage. And we have also as well some data processing algorithms, for example, processors from Snap. This interface is available via REST API as well as via OpenEO. There was a question before. It's a very basic implementation of OpenEO, so it's just allowing you to access the predefined workflow. So it's not the granularity that you have in CDSE, for example, on OpenEO. And users can also request to onboard their own custom hooks to the offering. We have the new increment, the fourth increment of development of DDL was just released. This brought a lot of updates. So we have a revamped user interface. We have what we call a user interface for managing the edge services or for requesting access to them. We are in the process of changing the way in which you request access to edge services. Via this interface, it's going to be easier to manage your own users, for example, and get quotas and different quotas for the different services and so on. And we have a new version of the HDA that brings also XRA support for certain data sets and as well as improved asynchronous provider handling. In the Stack offering, we brought Binder Hub and also we introduced what we call a notebook gallery. We have improved monitoring, allowing you to see if there's a problem with the federated data provider or with one of our services in case you cannot access the data. And we have as well new data sets that we brought over. Just to give you a glimpse of what's coming this year, so in Q4 we are going to release increment 5. We are going to continue updating the notebook gallery. There's going to be more data integration in HDA, stack optimizations, a way to access HDA via API keys. We are going to add as well AI training data sets. There's going to be dynamic resource management, and in a separate activity that we call DeFair, so the Destinationers Framework for Preparing AI-Ready Data, we are going to have a release of the minimal viable product for preparing AI-ready data. If you access this QR code, you can see one of the demonstrators that we had on the DestinE Data Lake for the Danube Delta Water Reservoir monitoring. It was a nice showcase of the different services and how to put together, so how to combine resources on the DEDL with resources on the European Weather Cloud in case we have users that have a footprint in both systems, and also how to bring your own data, how to access digital twin outputs and federated data. So I invite you to have a look at this. And just to say again that we are open, so the services are open, they are free, and you are welcome to submit your project proposal and contribute to DestinE, so to become part of this ecosystem with your project. Yes, so I'm going to leave the QR code here for you to access, and thank you very much, and if you have any questions.
Thank you very much, Miruna. Again, if you want to raise your question on Slido, please do. Otherwise, there are still 2 microphones in the room. I will start by the first question. I'm not sure. So, okay, super. Will this presentation be available somewhere?
Yes.
I get the positive answer from Franca, thank you. So they will probably be available in the DestinE website, in the event section. At least you will be informed when it is available. Thanks a lot for the question. Any other? Yes?
Hello, yeah, thank you. Oops. So, thank you for the presentation. I have a more practical question. Is there a possibility to have an overview on where to find which data, which indicators, before having to go in everything? So basically, a bit of really just overcate, if I'm interested in droughts, for example, where do I find which type of drought indicators? Are they only in this environment? Are they maybe, these kind of things. So is there something where I can look before so that I can actually decide which level I would need to go? Thanks.
Yeah, so you can directly go to our user interface, for example, of the DEDL, and then we have a free text search. You don't need to be logged in or to have an access to our account. And I think it's the same for the digital twins. There are these fact sheets that you can access. So normally it's only to download data that you need to have an account, but just to explore or just to get in contact with us, you can address a request, and we are happy to support.
I can complement. I think also for each services, which are not only the data lake one, there is the list of data used within these services on the user platform.
I have a practical question of using ILS service. And you say there is a GPU available on the service, and we're currently working on several AI ML demonstrators. In terms of process, how does the approval of using GPU?
It's the normal process, so to say. So you submit a request for resources, and then you describe your project. You describe the size of your application, and if you have already experience with using GPUs, so you know already pretty well how many resources you need. You describe all this, and we are going to onboard you. There's another thing to say.
Just want to avoid that we have confusion. So on the data lake, on the edge services, there are limited amount of GPUs and resources available. So by no means we will have capabilities like on HPC compute. So So if you need resources on HPCs, then you would have to go, for example, and request it through an AI factory or etc. if you need that, or by other means. So in the data lake on the edge services, you can do maybe small-scale model development where you can use
demonstrator. So then
yes.
I was assuming it's not a full-blown
yes.
foundation model or something.
Correct.
No, it's some small demonstration, proof of concept type of experiments.
Yeah. But I just want to put it into perspective because maybe sometimes it could be misunderstood.
Yeah, sure, thanks.
And maybe what you mentioned, you can submit your project, but I guess there are boundaries and not any project can be developed. What are the constraints?
So normally the project should have let's say, it should be of interest to DestinE and to the goals of DestinE, and there is a strong wish that you use digital twin outputs. So it's not, let's say, I need GPU, so then I will go to destination Earth. It has to be, because all this goes, it's an approval via the EC, so it has to fit in the mandate of destination Earth. Yeah.
Thanks. I don't see any another question.
We have a question on Slido, general question, what 3D engine is used in DestinE?
So I'm not sure I understand the question. In what component? Do you mean like for visualizations or, because I mean, at least on DestinE Data Lake, we don't have a visualization service. I know that there were some experiments maybe in ECMWF with the Unreal Engine. There were some presentations. Yeah. Yeah.
Yes, with Unity.
Unity, okay, yeah.
Okay, so thank you very much, Miruna.
Thank you.
Then I would like to welcome the next presenter on stage, which is Fernando Iglesias from Predictia, and he will be presenting AI for Clouds application demonstrator using AI, Destination Earth.
Hi everyone. Today we'd like to present our demonstrator, AI for Clouds. It's to enhance ExtremeDT Cloud Forecast. It's a contract managed by EUMETSAT, and the consortium is formed by yourself, Predictia, and CSIC. So very briefly on the context, because we've been hearing from yesterday, we know that DestinE aims to create this digital twin of the Earth to enhance our ability to respond and adapt to both extreme weather and climate change. So in this work, we are mostly interested in ExtremeDT simulations, which will support our decision-making to rapid responses to extreme events. It may be due to meteorological, hydrological, or air quality reasons. And these simulations are high resolution. They explicitly resolve deep convection, which is very important for clouds. And it's the IFS NEMO system. It's developed by ECMWF and also operational AI by them. And they already showed yesterday that ExtremeDT already outperformed in a number of diagnostics and metrics the control or the operational version. For example, here they show how DestinE is able to better get the maximum wind speed due to tropical cyclones. But what I'd like to highlight here, that we saw also yesterday, that these simulations have systematic biases. And the question for us is that how can we use artificial intelligence to merge ExtremeDT simulations with satellite measurements to enhance short-term cloud forecast? And we'll try to do so for a concrete application in the solar energy sector. So just to give you an overview of this work, our ultimate goal is to develop an artificial intelligence solution, as I mentioned before, to enhance short-term up to 12 hours cloud forecast of ExtremeDT simulations, and that is by merging them with satellite observations. So our specific goals is to provide an improved accurate cloud forecast, including uncertainty representation, delivering a well-documented open source model, fully deployed under a DestinE operational ecosystem. And as I mentioned, it's the potential of this demonstrator is on the energy sector. And for that, we are in partnership with an end user that will help us do so over the Iberian Peninsula. So in this presentation, I'd like to highlight 3 key points. First is the approach we are taking to develop AI for clouds and why we are doing so. The machine learning framework that we will use, and the tool that we will use to evaluate, and the infrastructure that will support this emulator. So regarding the approach, how can we map extreme DT simulations with satellite measurements? So we know already from yesterday's presentations that these simulations have systematic biases compared to observations, but we also know that they are initialized from analysis, and also they are high resolution, explicitly resolving deep convection, very important for clouds. They are also short-term forecasts, and that really help limiting the error growth of these simulations. But still, the question remains for us is how can we merge and use them to improve cloud forecast? So initially, we thought about a post-processing approach. This is bias correction. There are well-supported methods. Just typically adjust the model outputs, removing systematic biases. But there are some limitations. There are biases that cannot be removed, and also it's a post-process approach. So we are really dependent on the existing simulation. But then down the line, we also realized that at some point, extreme DT cloud fields are not publicly available, at least for now, so we cannot do this method. We've been thinking, what else can we do? And in the last few years, we saw a race in machine learning weather forecast systems, such as AIFS system from ECNWF, with great potential, actually outperforming in a number of metrics, state-of-the-art numerical weather prediction systems. So we thought that we can build here an end-to-end AI forecast system in a way that it will implicitly capture and correct these biases in extreme DT simulation by combining thermodynamic fields from extreme DT, which are available, temperature, relative fields, and so on, with satellite cloud fields. And when available, or if it's at all available, clouds from extreme DT, this is compatible, and we can include them in the emulator. Regarding the machine learning framework, we will use an MOE. It's a machine learning framework created initially by ECNWF, and now it's co-developed by different meteorological agencies. And also is well adopted within DestinE for developing this kind of machine learning, weather, and climate forecasting system. We've got the climate emulator poster in the back. What I mean here is that this framework is well supported and the community is growing. So it really, we can benefit from this framework. And also, it's providing us a holistic framework. So we can do everything at once. We can prepare the training data set, we can do the training, and once the emulator is ready, we can actually do the inference. We can do the forecast with the emulator. How will AI for clouds look like? We will adopt AIFS system. This is an encoder, processor, decoder architecture. As inputs, we will have some forcings, the day of the year, insolation, latitude, longitude, coordinates, and so on, and some prognostic fields from extreme DT, temperature, relative fields, specific humidity, and so on. And the emulator will take the state of the system and advances into time. So we will get not only the prognostic fields from extreme DT, but also cloud fields from satellites. So the emulator will learn the mapping, adjusting for the biases in extreme DT simulations. And because this system is autoregressive, we can extend the forecast indefinitely in time. A couple of considerations for this emulator. We are doing here a stretch grid. This being because we are just interested in over the Iberian Peninsula, but with a stretch grid, we will emulate the full globe at lower resolution everywhere else and high resolution over the Iberian Peninsula. And regarding uncertainty, we have considered different options, whether developing a stochastic model, but we are in contact with different meteorological agencies, and we learned that this kind of emulator is not mature enough. So we will go and develop a deterministic model and then provide uncertainty via ensemble forecasting. So finally, regarding validation and infrastructures, we adopt Aqua. Aqua is, we saw yesterday, it's an evaluation framework developed for DestinE that allows us to access processing and analyzing DestinE simulations. It already includes a number of diagnostics, particularly for climate time scales. And we will expand with additional machine learning metrics and weather scale diagnostics that at the end of the line will be available for the community. Regarding the infrastructure and services, we've been learned a lot about DestinE platform. This emulator will be fully focused on using DestinE platform. We currently use islet, both cloud computing and storage. We are using HDI to access and retrieve data. And our code is based in UMETSAT GitLab, ensuring high code quality and security checks. Unfortunately, we recently started this work, so mostly we bring is an overview of the concept. Currently, we are working on retrieving extreme DT and aligning them with satellite data before we can even start training some prototypes of AI for clouds. But we do have some other data sets that allows us to start playing and getting familiar with this kind of AIFS stretch grid system. So we can start getting familiar with how to train and optimize this kind of emulator. So we bring today, just for visual inspection, doesn't have any scientific value, a forecast of how the system may look like, for example, for cloud cover and incoming shortwave radiation. So you see that it's not running. It's not running. It was a gift, but you see that we will emulate the full globe. We are focusing on over Europe, and then over the Iberian Peninsula, we will have a higher resolution that will allow us to improve cloud forecast for the energy sector, and that will be in partnership with an end user in Spain. That's all from our side. Thank you.
Thank you very much. Is there any question in the room? Yes, I can see one. There are microphones. Okay.
Thank you for the very interesting presentation. I have a naive question. If you want, should you start over again your journey? What suggestion do you have for newcomers? Suppose I want to do something similar. What are the main steps, or what are the hints, tips you can give to somebody who starts using basically the platform as you did?
You mean for developing a machine learning emulator for weather or climate purposes?
Yeah, something along this line, yes. Start using the system. I mean, using the system as you did, basically.
So, yeah, we recently went through that process because we are also building the climate emulator for DestinE. We were thinking on different machine learning architectures. We were suggested to use an MOE, and now we are very happy to do so because the community is growing. There are different groups, meteorological agencies working on this, and it's really well supported. You can benefit from other people's experiences. If you find some issues, you can always talk to the core developers and do your own. So I find this kind of machine learning framework a very nice starting point, because you are not starting from scratch. You've got some experience, whether you want to develop a full climate model or a weather system. There are different configurations, and you are not starting from scratch.
Okay, thank you.
Thank you.
So thank you very much for your presentation. It's very interesting. I just have one question that might be silly because I'm just discovering these DestinE services. But in your presentation, I think you mentioned a 4.4 kilometer resolution for the best resolution. Did I understand well, or do you intend to have a higher resolution? Because I'm thinking about some events that can really clearly affect solar energy, like fog forecasts. And for me, it seems that a 4.4 kilometer might be too large. And even with the higher resolutions, we know it's really problematic with current digital twin simulations, but also with satellite observations, lacking informations. So for such cases, do you have already ideas to use other data sets like ground-based measurements, for example, for the solar energy sector?
Yeah, that's a good question. So regarding the resolution or the simulations that we will use, we will start with global extreme DT simulations instead of on demand, because this is just a demonstrator. See how far we can get. Also, we don't want to emulate or learn noise. Probably we'll actually coarse grain these simulations, let's say to 10, 20 kilometers to start with, and learn actually those mesoscale signals instead of noise. That's the main purpose, and then we can see whether we can push further with the resolution. And regarding measurements to compare with, in addition to satellite one, we are in partnership with this end user that will provide us with in situ measurements.
Okay, thank you.
One last question, and then we need to move on.
So hi, thank you for the great presentation. So I'm just sorry I asked a very technical question. So you had that part of this, your machine learning part, which is, yeah, that one. So I was just a quick question. So what kind of grid system do you use to?
What kind of?
Grid system. Do you use a latitude, longitude, you know, the grid system, or do you consider the Earth as a sphere and then you use such?
I see, I understand. So we are not constrained by the grid because an MOE is flexible. You can use latitude, longitude, regular grids or Gaussian grids if you like. You can also use octahedral grids or Helpics.
Thank you.
Yeah.
Great, thanks a lot for the question again and for your presentation, Fernando. This is, the next presentation is from Barbara Borgia from ESA, and she will present the platform for partnerships.
Okay, so hello everyone. I'm Barbara Borgia. I'm part of the DestinE team at ESA, working on the platform. And today I will introduce you a new feature that we recently added to the platform, and that is called tenancy management feature. So this feature is actually a change of the way we manage resources inside the platform, and is a flexible model that is really designed to enable the work, the collaborative work of organization on the platform, benefiting from all the available service resources that are already implemented and present and operational on the platform. So as you can see from this slide, currently each user on the platform can individually consume the service resources. What we are doing here is basically enhancing this paradigm, allowing groups of users to work together on the platform with a set of enhanced and segregated resources available for the project, for the partnerships. Why we do this? Well, we want the platform really to be the place where projects related to climate change can take place, can work together with the resources that they need, but benefiting from all the technology, the data sets, and the service capability that are already developed. With the introduction of the tenancy, registered users will be able to create and to manage these organizational groups, which are called tenancies, so groups of users. And as you can see from the diagram here on the right, tenancies are hosting projects and resources are allocated to projects. So this is really the granularity that we would like to have in this scenario. And as I was introducing before, this new model is introducing a collaborative access to services. I mentioned many times the word resources, so just to clarify a little bit what we mean with that. On the platform, the concept of resources is defined in compliance with the definition of the Data Spaces Support Center blueprint architecture, because we are aligning as much as possible the architecture of the platform to this set of specification. And therefore, with resources, we mean data set and data services or service functionalities. On top of this, we are adding in this scenario the concept of collaboration. So collaboration tools are part of the resources as well. This feature, as I was saying, is already in operation in a first implementation. And I show you here in this slide the current configuration that we have in place. As I was saying, this is really a new way of managing all the processes related to resource management. So what we did to implement this is to define a first big tenancy that we call the free DestinE tenancy. And inside it, we have a project, because we saw from the diagram earlier that this is really nesting tenancies and project one inside the other. And all the registered users of the platform are now belonging to this free DestinE project. You can see it from your user profile. When you log in on the platform, you will see two tags. One is related to the tenancy, one to the project. And for the one of you which are also upgraded users, so you have the right to access to the digital twin data, you will have another tag dedicated to this. The next step that we will do now is to implement a dedicated project for users which have the upgraded access. So at the moment, it's still implemented through a policy inside the IAM, but this will change and be compliant to this new model. If we have a look at the service provider point of view, I mean, why the tenancy is key and it's important for service providers. Well, in short, I would say it's really a fast track for user uptake. It allows service provider to reach agreements with organization to make available their capabilities to a wider set of communities. And the process to request the enhanced set of resources for a project is the one that you see here at very high level. And another point I wanted to stress here is that with the tenancy, we are introducing three main winning points for service providers: visibility, control, and trust. And once again, this set of principles are really in line with what the data spaces are doing in Europe. And visibility, because also in this case, as it is already the case for the free resources, the entire offer of each service will be available in the service registry. So it's really a wide audience where someone can show the capabilities of a service. Control, because of course the service provider remain in control of their offer, can decide who can access what and under which conditions. And finally, trust. This is really key. As we are about to see in the next slide, we make sure that all the transactions related to service consumption are logged and can be also audited in case of need. Very briefly, this is the technical overview. So the set of components, first of all, as you see on the right, the set of components involved in the overall scenario. Of course, the IAM, so the Identity and Access Management Service, it's part of the scenario for everything that deals with authorization. Then we have developed a dedicated component for managing the tenancies that is called tenancy management component, and is responsible overall for the end-to-end scenario from the request of creation of a tenancy to the allocation of the resources. And finally, I would say the diamond of the scenario, the clearinghouse, which is the service that also implements the accounting function. Once again, this is a component that you will find in any of the blueprint architecture built in Europe for data spaces, and is ensuring that all the transactions are stored and logged, as I was saying. All the agreements between service providers and consumers are available and can be seen. And finally, is also providing the function of clearance for transactions. So really making sure that all the transactions taking place on the platform have the right of happening. On the other side of the slide, you see very briefly at high level how service provider can implement the tenancy model in their services. This process starts, of course, with the definition of the resources, the documentation of such offer in the service registry and in the IAM to ensure that everything is going okay end to end. And finally, of course, the integration in the platform and the actual deployment of the resources upon request of the tenancy admin. The tenancy admin, as you might have seen in the previous slide, is the user that has the responsibility to manage a tenancy and also manage all the invitation for members to join. So it's really the responsible for the overall life of the tenancy. Finally, I wanted to show you here that we have a service already implementing this compatibility, that is Delta Twin, and now it's possible to request, on top of the free resources, also an enhanced set of resources, so a custom set of daily runs and parallel runs on the service. Another service is coming shortly to be compatible with the architecture, and it's there. Generally speaking, all the services of the platform will implement this according to our last run of best practices. And of course, for all the service providers that are going to do the onboarding on the platform and are interested in implementing this kind of architecture, all the information will be part of the onboarding starter kit. And yes, this is closing my presentation. Don't forget to vote to the survey. Thank you very much for your attention.
Thank you very much, Barbara. Is there any question in the room? Otherwise, I have one already. So this tenancy management, the two last services you mentioned, Delta Twin and DEA, they are taking advantage of these resources? Or, yeah, okay, so they are part of the tenancy, they are a tenancy project per se?
No, not really. Well, the tenancy implementation is done on two sides, we can say. On the core, on the platform management services of the platform, so the core set of services, and then there is an implementation that is done at service level. So the resources exposed by Delta Twin are the runs that a user can do within the service. And it's possible to allocate an enhanced set of such resources in a dedicated tenancy. So to allow this, a user should create a tenancy and create then a project and request these resources to be available.
Okay. And then I can see some similarities with the previous presentation of the edge services. I guess there are different purposes for both.
Well, yes, I mean, it will be, in this case, available for all the services of the platform. So if a project has the need to use many of the services available, can create a tenancy where everything is wrapped in a certain sense, so that users will be able to work together collaboratively with the necessary resources.
Thank you. Any other question? I don't know if in Slido we have one. No, otherwise we will welcome our last speaker. This is the other side.
Yes, so we welcome on stage Claire Villian, that she will explain, he will explain a collaborative toolbox to build and share your digital twin components.
Good morning, everyone. As you see, I'm not Claire, it's my colleague. So I'm very happy to be here with you for this first user exchange. It's a nice opportunity for us to get feedbacks and improve our services according to your expectation. So today I'm going to introduce you two services developed by Gail System and available on the DestinE platform, Sesamio and Delta Twin. To start with, I will give you an overview of Sesamio, an Earth observation data catalog designed to work as a complementary service with Delta Twin. So the idea behind Sesamio is to serve as a single entry point for accessing all your dataset, whether they are Earth observation data, statistical data, or other types. It acts as a bridge between you and various providers' interface, offering a unified overview of all your data collection in one place. Currently, the service supports 5 main data providers. Copernicus Data Space Ecosystem, which offers access to all the Sentinel mission products. Destination Earth, the data lake, managed by EUMETSAT. And we give access to statistical data like Eurostat and UNICEF. We have also a connection with data cache management service available in DestinE platform. The key advantage of Sesamio is first, it's a centralized access. It works as a proxy for all your dataset. It's a complementary service connecting with Delta Twin. It's customizable. You can add and create your own collection for access faster later. And we try to propose an evolving roadmap, so based on your feedback and your expectation. Now we know more about Sesamio, I will introduce you Delta Twin. So Delta Twin is a collaborative working environment that enables the design of processing blocks to fit components of the Earth's digital twins, such as urban heat island, air quality forecasting, and change in the water cycle. Processing blocks can be reused to build a more complex digital twin. With Delta Twin, your data is ready for interaction with external systems, thanks to compliance with industry standards. Delta Twin is a web platform that facilitates multi-stakeholder collaboration, makes it easy to share knowledge and turn data into concrete action. As a developer or a scientist, you can wrap your code in a Delta Twin component, and as a local authority, you can monitor the indicator of your component to help you make better decisions that are more respectful of current constraints and challenge. As you can see, each element block you can build with Delta Twin follow a life cycle. So first step is configuration, then you can deploy your blocks. After, thanks to the service, you will allow to run your blocks and share the data provided by your processing. On the left of this slide, we have a great collaboration with Collab Atlantic, which show Heat Island in the region of Lisbon. So to access the service, you need to have an account in the DestinE platform. After logging, you will arrive on your workspace. So here it's a workspace of Delta Twin services. This page is divided in 2 main sections. On the left side, we have a navigation bar. With this navigation bar, we can access to Delta Twin. It's a processing runnable project in the service. You can access all your Delta Twin components. You have also storage in Delta Twin, where you can store your artifacts. Artifacts are a result of all your process you run with Delta Twin. and you have resources. You can put all your data you want in the services, and this data can be used as input or parameter of your Delta Twin component. You have a dashboard. In this dashboard, connecting to the tenancy services, you have some KPI and metrics to know which processes are currently in execution. You can schedule your run. You have also a view of your latest computational resource, your last artifact. And on the right side, we have the starter kit. So starter kit are components already available, ready to use in your Delta component to create your project more faster. And we plan to expand the starter kit with based on the community need. So let's go more in deeper what a Delta Twin component is. So each Delta Twin component has an identity panel with some information. So you have the name, you have the visibility. The visibility can be public or private. You can manage different versions for your Delta Twin component. You can add a description. Also, you can specify, get information about the input of the processing, the output. You can add information about some external information about the component. You can add topics for better search later. And we see also the status can be public and private. So in the workflow tabs, you have an overview, diagram flow of your process. So we see the input on the left, the output on the right, and all the function that is used in this chain. On the top right of this page, you can launch a run. Run can get some parameter. You can, for example, in this situation, we use date and hour as an input. And then you can submit your run and see all the status of the past, current run. Once the run has been executed, you can, during a period of 48 hours, you have two possibilities to get the output result, the valuable data. Once it's downloaded to your local machine or saved as artifact, this result will be stored in the Delta Twin services. One important point is all the output generated by the Delta Twin component can be structured based on a standard structure like smart data model, which allow connection with external system and very useful to use in the context of urban twin. So here we have a page where you can have more detail about all your artifacts with a quick view of the output when a visualization is available. You have a subset of the data can be connected with the external systems and some information about the author and the topic concerning. So you can then export this data and use for external application that can be more readable human information. So how to create your own Delta Twin? To do that, we give you here on this slide a quick overview of all the steps to go and provide some valuable data. First, you have an algorithm, a code, an AI model, or anything that give value to the data. Currently, we support Python code. So you can embed your code in a Delta component project structure. Then with Docker, you will build the Delta Twin component image. Then you can publish this image on the service, on the cloud infrastructure. This processing can reuse some bricks from the starter kit, can also use a data source available in the Sesame services. You can reuse your previous artifact generated. so you can give more and more value to the data. The data can be raw data or more visualizable data, it depends. And then finally, all this data can be provided in the DestinE ecosystem to feed some other services. So to help you to onboarding this service, we have many resources. We have a text-based tutorial on the website DestinE platform. We have some video tutorial on the channel of Gale system. We have also many samples on GitLab. You can easily download some source code and run your build and run your own Delta Twin. And finally, since we are the first user exchange, I would like to highlight the DestinE Service Public Roadmap, where you can stay informed about upcoming features and share your idea to help us to develop service that truly engage users. That's it for me. I hope to see you soon on your services. Thank you very much.
Thank you very much. Is there any question in the room? Online neither, but I have one again. Ah, there is one, sorry. Please, okay.
Hi, thanks for the great overview. I just wanted to understand how is the offering of Delta Twin and Sesame.io different from what we saw earlier? Like if you consider some of the platforms for also running your own workflows and also the harmonized data access for data discovery, when would you, for what use cases do you think this is much more suitable than the other offering? Thank you.
Really good question, thank you. From my point of view, there are several users with several skills and knowledge, and sometimes the experience can be improved with more content to guide to onboard the system. I think it's a good thing to have many choice, many services to go and provide to the market the different persona or other needs. So we work a lot to make sample products to open to everyone. And it's an important one. We want to propose for decision maker some interface and easy information that they can use to make decision. And that is our goal today. Maybe something different, but it's good to have many offers because that can improve the technology. Yes.
Thank you. Yeah.
Yeah. I think that my question is also linked to the previous one because I think that this Delta Twin is really interesting. I have been testing a little bit on it, and my question is also with regard to the artifacts because there are some examples there and images that can be used, but what happens is that you don't know what is behind that image. You don't know how is the workflow behind that. And I was wondering, and on the other hand, I think that the good thing of Delta Twin from my side is that you can create a community based on what others have already done and public and create workflows with that. My question is, what about applying this philosophy also to the other examples that have been shown previously? Could we create a community of things that have been done so that anyone can make workflows with other previous examples, etc.?
From my point of view, it's taken a long time to build a community with a SaaS product and engage people and explain what is the purpose of this service more and more in Earth observation area. So we will do some content to explain, guide, and we don't we have to try and support your users, but we don't know how the future is.
Thanks. Yeah, I can complete and say, I think all those services are made to interact together and to satisfy the wide community of users. And we should, I think, yeah, at least on the services you might develop, explain through articles, etc., what services have been made for, how it worked in the backend to inspire the community. Same, I think, for other applications developed on other services. Yeah, I hope you, along the presentation, you saw there are some connections, they are linked, and we try to reuse at best what has been developed, let's say. Yeah. You want to get the microphone, maybe?
Maybe we need Ines or someone from ISA, because on the core platform there will be something established which allow these discussions taking place, these moderated forums, etc. So there was a plan to do something like that, which was just mentioned. Maybe Katrin, you explain.
Yes, thank you. No, we are working on several ways to collaborate. Also, Delta Twin is already set up to allow collaboration. And maybe just to highlight what distinguishes Delta Twin from what we have seen before is that it's open to everyone. So when you are not qualifying for the edge services, you are welcome to use the Delta Twin service, and it's scalable. So you can start small and then scale up, as we explained yesterday. And we really look forward to get your feedback.
Thank you. So this is the end of this session one, for session one of day 2. We had many questions. I'm very happy about that. We have not, the moderated session did not happen, but I think I prefer to have questions to have a broad comprehension of each speeches. So you have food at the back of the room, coffee, and we reconvene in 1 hour and 25 minutes.